Problem 7 states, two bodies are falling with negligible air resistance side by side above a horizontal plane. If one body is given an additional horizontal acceleration during its descent, then gives us a bunch of options. So, concept behind this is that basically there's no horizontal and vertical components of velocity, acceleration, displacement, anything to do with kinematics have nothing to do with one another. You can have anything going on in the horizontal, and it does not affect anything going on, what's going on in the vertical. So if you have an object dropped straight downwards, it's dropped. And you have another object thrown horizontally. You have another object with a jetpack that's causing it to accelerate horizontally. But they're all falling. Nothing going on in the horizontal matters, okay? They all have an initial velocity of 0, they all have a gravitational acceleration downwards, and they're all going to hit the ground at the exact same time, pending that they're at the exact same height and they have the same displacement. That's the end of the story. Horizontal and vertical, it's a weird concept at first. Hopefully by the time of the test you guys have kind of gotten used to the fact that horizontal and verticals usually have very little to do with one another, but you can pretty much always separate those vectors up and not deal with them. Horizontal acceleration has nothing to do with what's going on. This guy and this guy are going to hit the ground at the same spot. One's going to be much further away from the other one, of course, but they are going to hit the ground at the exact same spot. Second choice says, has the vertical component of its velocity altered? Just said that. It's not going to affect anything. Horizontal acceleration only affects the horizontal velocity component, not the vertical one. Has the vertical component of its acceleration altered? Horizontal acceleration has nothing to do with it. You're still going to accelerate downwards at the rate of gravity. It follows a hyperbolic path. If it's given an additional acceleration. It could be, I think, if it was given the acceleration due to gravity, then it would follow a diagonal path. It'd be a linear path. So right there's proof that it won't. If it has an acceleration due to gravity downwards and you give it a 9.81 to the right, then it's just going to go in a straight line like nothing's happened. It's going to keep going faster as it goes down that line, but if you have the same acceleration in the same way, then it's just going to give you a straight line. So, there's a reason why that one's not true, because though it could possibly be true, it doesn't have to be true. Follows a straight line path along the resultant acceleration vector. I just gave you the situation where that's true, but if the horizontal acceleration is not equal to the vertical acceleration, then it won't be a straight line path. It won't be a straight line diagonal. If one of them is accelerating a little bit faster than the other, it could, instead of this, you could end up with one of these, I think, or one of these. I'm really not even sure. I just know it wouldn't happen that way. It wouldn't be in a linear path. It would be doing something different. So sure, you can figure it out with enough calculus involved, but for this test, the only thing that matters is knowing that the horizontal has nothing to do with the vertical, therefore they're going to strike at the exact same time. That's the key concept of this problem. And that's it.